This video gives you a brief overview of our research titled Matching Mind and Methods, Augmented Decision-Making with Digital Companions Based on Regulatory Mode Theory. In short, we set out to explore if we could support human decision-making, in our case, the choice of an apartment, with an assistant technology by applying an established theory of self-regulatory processes. Our goal was to create a technology that not only supports people in their decision-making, but also makes them feel good about their decisions and the involved companion. The title already implies that our work builds upon three pillars, which are augmented decision-making, digital companions, and regulatory mode theory. First of all, when we talk about digital companions, we mean technologies that are able to adapt their functionality to the individual user's current needs, to react to changes of context in the environment, to be sensitive to the user's emotional state and disposition, and to conduct helpful and informative dialogues. Decision-making is just one potential field of application for such technologies, but it is an important one, as every aspect of our life is dependent on making decisions, and hopefully good ones. Of course, many decisions in our life are quite intuitive, like, what should I eat today? Or, is this the person I want to be with? But we often also have to make elaborate decisions that require the consideration of data in conjunction with our subjective evaluations, like, which car should I buy? The notion of augmenting such elaborate decisions has been around for at least half a century. But even today, technological support throughout the whole decision process is still scarce. For example, imagine people who are looking for a new apartment. They may browse the web for offerings and end up with a defined set of alternatives at some point. Maybe they used comparison portals and filters for certain features, but those applications usually do not consider the relative importance of attributes, or the user's mindset, or their preferred strategy. We assumed that if we can provide this with digital companions, people would be more satisfied with their decision process, their choices, and the supportive technology itself. But how could we do this? To this end, we applied a psychological theory called regulatory mode theory, which distinguishes two processes that take place during human goal pursuit. On the one hand, we assess desired end states and means to get there, which is labeled assessment mode. On the other hand, we are also concerned with initiating and maintaining the steps that get us from our current state toward desired end states, which is called locomotion mode. For example, if someone wants to get fit and healthy, they have to assess which kind of meals serve their goal the most. But they also have to constantly engage in the step-by-step process of planning meals, buying ingredients, and cooking them. So to reach their goal, one could either follow the motto of do the right thing or just do it. Previous research has shown that people may experience a subjectively positive state of so-called regulatory fit if the way how they pursue a goal fits their currently dominant regulatory mode. In those cases, people experience a sense of feeling right about what they are doing, which gives subjective value to their current activity. For example, people in a study who were to choose between several book lights were willing to pay more for the same book light if the way they came to their decision matched their regulatory mode. This fit was given when people in an assessment mode considered all available information at once, hence a full evaluation strategy, or when people in the locomotion mode successively excluded options until they ended up with a choice, hence a progressive elimination strategy. Now, we brought all parts together. Our assumption was that such a state of regulatory fit during decision tasks could also be induced by a digital companion, and that this effect would not only enhance the subjective value of the decision made, but could also spill over to the evaluation of the companion itself. On a side note, we also explored whether people are objectively faster or more accurate. To test this, we conducted an online decision experiment with 81 participants. People were told that they will be given a set of different apartment descriptions, and would have to find the best option for themselves. In their decision process, they would be supported by a new assistant technology called Companion. But first, Companion would have to ask them for some information about themselves and their preferences to give them customized advice on how to proceed in their decision-making process later on. As instructed, people first answered a questionnaire, which we actually used to control for their chronic regulatory mode tendencies in the analysis. Then, they rated apartment attributes according to their subjective importance, which later allowed Companion to sort the information accordingly, and it gave us the opportunity to calculate each person's optimal choice afterwards. Following this, people were induced with an assessment or locomotion mode by the Companion. In a few sentences, Companion advised them that it is best to follow a do the right thing or a just do it attitude when one is stuck in an ambivalent state. Afterwards, Companion created conditions of regulatory fit or non-fit by presenting available information according to one of two strategies. With a full evaluation strategy, people chose their apartment from a table that showed them all available information at once, sorted by importance. With a progressive elimination strategy, people chose their alternative by excluding apartments step by step, based on how they perform on the most important attribute, then the second most important attribute, and so on. After making their decisions, participants evaluated those decisions, the Companion technology, and their mood during the task as a control variable. Apart from this, we measured their decision speed and calculated their decision accuracy, which was the deviation of their choice from the best choice based on their initial attribute ratings. The following analyses supported our assumption that people would be more satisfied with their decision if they made it under conditions of regulatory fit. There was an interaction effect of induced regulatory mode with decision strategy, indicated here by the crossing lines in the graph. This effect even increased when we controlled for mood and people's chronic regulatory mode tendencies. Even more important, this also applies to the evaluations of the Companion. We could demonstrate that the user's experience of the Companion was improved when it supported a decision strategy that matched the respective mindset of the user. Interestingly, we found no significant differences for the objective criteria of decision accuracy or speed. In conclusion, our study that matched the mind of the user with the corresponding decision method provides three implications. For augmented decision-making, matching mind and method can create positive user experiences independent of decision accuracy or speed. For regulatory mode theory, this means that subjective value from regulatory fit can also transfer to the technological means involved, which has not been shown before. And finally, our exploration can also inform the design of assistant technologies that are aware of the individual user's state, making them qualify as actual digital companions.